AOC, day 4. Okay. The first, okay, this is actually useful. Oh, it's the number of winning numbers? Oh, wait. Each match after that doubles the point value. Okay. Okay, so the first one is just the card number, which I don't care about. And then question is, it's just the first 10 numbers. And then those are the winning numbers. And then the numbers we have. Okay, so these are the winning numbers, these are the ones we have. And then the question is, is that right? Rank 7? Oh, you win copies. Interesting. It would then win a copy of the same cards as the original. Oh, I see. Oh, this is like a DP style-ish thing. Okay. Total. Okay. Cool. I think what we do is okay, so this is just going to count the number of matches. And then what we can do is, it's a little unnecessary because we already have the information. Okay, so now R is the number of matches. Cards will never make you copy a card past the end of the table. Okay, it's a nice guarantee. So basically, win 5 plus. Oh wait, this is just the sum of. Oh, I see. No, because the copies all function. Okay. So the mult is just going to be win I. The win of I plus j plus 1 plus equals 1. And then plus equals mult, my bad. Okay, and then I think it's except the initial mult is 0. So I think this should be actually, we start with the 1 card of everything. Is that right? The original card too, so you win 1 copy. Your copy also, yeah, okay. So you start with 1 of everything. And this should cause us to, okay, let's just try it. Rank 5. Whew, 7 and 5. Okay, that's a pretty good day. I am very happy with 7 and 5. Oh man. Wow, 1:22, that's insane. How do you even get this fast? Yeah, that's just wild. And on the first one, I was, okay, yeah, minute 36. Oh. Yeah, I had this little utility function prepared, which is from my like AOC tools thing, and it just gives you all the numbers on a line. And that actually worked out to be somewhat useful here, although I had to count the number of numbers. Maybe if I just built on the pipe, it would have been easier. Not really sure, but okay, yeah. So I guess I'll go ahead and explain the solutions for today. So the first part basically says, this is just like a parsing problem. So like read the numbers before the pipe. These are the winning numbers. Read the numbers after the pipe. These are your numbers. And just count how many of your numbers appear in the winning numbers is all it asks for. So like 83 is a winning number, 48 is a winning number. I'm trying to see if I had any more. No, those are only 2 winning. Oh, card 1 is 5 winning numbers. I'm really bad at counting. Anyways, but yeah, and the wait, am I reading the right thing? Card 2. Oh yeah, okay. They just have the example here. Sorry, I got confused by the example. I was like, why is it not explaining card 1 here? Anyways, you just count the number of matching numbers that are winning, and then the like value of your card is 2 to the number of winning numbers. Unless you have, 2 to the number of winning numbers minus 1. Unless you have 0 winning numbers, which case is worth 0. So the value of a card is like 0, 0, 1, 2, 4, 8, 16, and so on. So for that part, you kind of just like, I don't know, you kind of just do it. Just like figure out the winning numbers, figure out your card numbers for your card number. I mean, obviously be more efficient if this were like a set, but it doesn't actually really matter because this is only 10 elements. It's not very fast. It's already very fast. And you just do the logic and you add them all up. The second part is like a little trickier. And the idea is that now, instead of actually winning points, if you had like 3 matches on card 1, then you win a copy of card 2, a copy of card 3, and a copy of card 4. But then the part that's tricky is that now your copies of card 2 can also win more cards. Basically, since you always win cards below you, the way to do this is you like compute your card 1 wins, and you just sort of tally up like how many of each copies of each card do I have, which for me is given by this win dictionary. And at the very beginning of the loop, so once you start processing card 3, you know you already processed cards 1 and 2. So you can't, so the number of copies you have of card 3 right now is exactly the number of copies you will have. So maybe at this point you have like 5 copies of card 3. What do you do with this information? Well, you process the number of wins as usual. Maybe card 3 has 2 wins, so you get 4 and 5. But now, instead of adding, because we know we had 5 copies of card 3, we just add 5 copies of 4 and 5 copies of 5, rather than add 1 copy. And this is important because these like blow up exponentially. I'm sure we can see this if we, what did I change? Nothing, right? Yeah, so if we do, let's look at like the first 20. You can see that these are like growing exponentially. So if you had sort of naively tried to like reinsert cards or something, you would like very quickly it could be way too slow. But this is sort of, it's not even n squared. It's like, there's what, you can have probably at most 10 matching numbers. So you at most go 10 cards down. So for each card, you go 10 cards down at most. That's still 10 times n. So you don't have to worry about any exponential growth with this like adding mult trick, which is it's not that complicated, but I think coming up with it quickly here is the important bit. But yeah, so that's additive code day 4. See the leaderboard's full yet? I think it should be. Yeah, okay. Yeah, they started coming in really fast at some point. And where am I on global? Let's take a look. Oh, look at that. I'm now number 3 on the global leaderboard. I am quite happy about that. Cool. Yeah, well, we'll see if I can keep the spot. I think I will not be able to, but it's nice to be. I think this is maybe the highest I've ever been at any point in time. Like across other years too. So that's pretty exciting. Cool. Yeah, well, that's all I have for today. So I will see you all tomorrow.